Hello, friends. Welcome to our live broadcast. I'm Emily. Today's live stream focus on a core topic: causes and treatment of tension cracks at the beam ends of post-tension simply support box girders. First, let me provide an overview of our company. Our company, Shandong Boyoun Heavy Industry Corporation Limited, was founded in 2006 and focus on the R&D, fabrication, marketing, on-site technology services of steel formwork for bridge, viaduct, tunnel engineering. The headquarters and the main factory are located in Binzhou city of Shandong, China, with the international department located in Beijing. The annual output is more than 65,000 tons. Boyoun has been qualified by ISO QM system since its foundation. More than 30 patents have been approved each year. Boyoun has served over 1,200 infrastructure projects, mainly for high-speed rail, expressway, railway, highway, and other large-scale infrastructure projects with experienced formwork solutions. Cooperated with giant state-owned enterprises and well-known overseas construction groups. Over the years, we have gained extensive experience and expertise and built a strong reputation in the industry. We are dedicated to provide our customers with high-quality products and, more importantly, with excellent service and technological innovation. Having introduced our company, let's delve into today's content. In the construction of post-tension simple supported box girders, beam and tension cracks are a common and troublesome issue. Next, we will first an overview of the problem to help everyone understand its impact and importance. During the post-tensioning process of simply supported pre-stressed box girders, cracks frequently occur at the anchorage zones and beam ends. When the tension strength exerted on the concrete in the anchorage zone at the end of the compressed box girder exceeds the ultimate tension strength of concrete. Location concentrated rhombic cracks with varying widths appear at the beam ends. These tension-induced cracks not only affect the experience of the girder but also pose potential safety and quality hazards, directly impairing the durability of the main structure of the girder. In several cases, they may even lead to the scrapping of the box girder. Therefore, adopting necessary preventive and control measures and avoid the occurrence of tension-induced cracks is of great significance for ensuring the quality of pre-stressed box girders. This article introduces causes and treatment measures for tension-induced cracks at the beam ends of simply supported box girders. Understanding the hazards of beam and tension cracks is crucial for us to figure out what causes them. Only by pinpointing the root causes can we formulate target solutions. Next, let's conduct a detailed analysis of the causes of these cracks. Cause analysis: improper reinforcement arrangement to resist the local compression caused by tensioning 3 to 4 layers of cross-girder type anti-crack. Reinforcement mesh are usually arranged at the beam ends of pre-stressed box girders. However, due to narrow space and the interference of anchor-bearing plates and spiral reinforcement, the installation of reinforcement is inaccurate and forced to meet the design requirements. Meanwhile, the tensioning notches are generally designed as plain concrete without anti-crack reinforcement, which reduces the compression resistance of the concrete under the anchors. Besides improper reinforcement arrangement, the quality of concrete construction is also a key factor of affecting the occurrence of cracks. Next, let's look at the second cause: inadequate concrete fabrication. Inadequate concrete fabrication, in addition to the structural reinforcement of the girder body, anti-crack reinforcement under anchors and corrugated pipe positioning reinforcement are added at the beam ends of pre-stressed box girders, resulting in this reinforcement that hinders concrete vibration. Meanwhile, the obstruction of anchor-bearing plates, spiral reinforcement, and corrugated pipes also prevents the insertion of vibrators, leading to honeycombs and voids in the concrete at the tensioning ends, which consequently causes tension-induced cracks. After concrete pouring, curing work is often easily overlooked, but is actually crucial. Poor curing control can also lead to cracks. Let's move on to the second cause: inadequate concrete curing control. Premature formwork removal of box girder will cause water loss on the concrete surface and generate cracks. Delayed inadequate or non-standard curing by sprinkling water and covering will result in uneven moisture evaporation between the internal and external parts of concrete, reducing the shrinkage strength of concrete and causing drying shrinkage cracks. At the same time, it will also affect the strength development of concrete. As the core process of post-tension box girder construction, pre-strength tensioning control directly related to the structure strength stage. Poor tensioning control is another important cause of beam and cracks. Let's analyze this fourth cause in detail. Poor pre-strength tensioning control. During the installation of pre-strength systems, the pre-strength ducts are not perpendicular to the anchor bearing plates. During tensioning, the central line of anchorage devices, pre-stressed tendons and jacks are not concentric, leading to uneven tensioning strength. Eccentric compression on the concrete under the anchors at the tensioning end and subsequent concrete cracking. Tensioning can only be carried out when the concrete strength, elastic modulus, and age of the box girder meet the design requirements. Otherwise, concrete cracking will also occur. In addition to the above human-controlled factors, the structural deformation caused by pre-strength tensioning itself can also lead to beam and cracks. Specifically, the upward camber of the box girder induced by tensioning will cause compression at the beam ends. This is the fifth cause we need to discuss. Compression of beam ends caused by tension induced upward camber of box girders. Pre-strength tensioning will cause upward camber of the girder body, which in turn leads to compression at both ends of the girder. When the tensile strength on the beam and exceeds the ultimate tensile strength of concrete, the girder body will crack. To avoid excessive upward camber of the box girder, which may cause excessive deflection after girder erection and affect the strength performance of the girder body. Reverse camber is usually set on the precast bed to ensure that the alignment of the bridge meets the design requirements after construction. Another factor related to the deformation constraint of the girder body is the wedge blocks at the bottom of the girder. The extrusion effect on the beam and can also cause cracks, which is the sixth cause we will analyze. Extrusion from wedge blocks at the bottom of the girder. Wedge blocks of the girder body are usually arranged at both ends of the girder to adjust to longitudinal and transverse slope of the girder. Ensure horizontal close contact between the girder and the bearing, and achieve uniform strength distribution. After the upward camber of the girder caused by tensioning, the constraint of the beach blocks at the bottom of the girder will generate transverse friction force, resulting in extrusion at the beam ends. When the pressure is too high and exceeds the ultimate tensile strength of concrete, the beam ends will crack. We have comprehensive analysis to the 6 main causes of beam and tension cracks. Based on these causes, we are formulate target preventive control measures. Next, let's focus on these preventive measures, which are crucial for avoiding crack occurrence. Preventive control measures. The spiral reinforcement of the anchorage devices shall be closely attached and fixed to the anchor bearing plates to achieve the effect of shock absorption of spiral reinforcement and prevent girder cracking. Thus, longitudinal and horizontal reinforcement at the tension notches so that the distance from the extended end of the end formwork is not more than 3 centimeters and added end to the end formwork is not and add U-shaped reinforcement to form an anti-crack reinforcement mesh. Replace the well-shaped anti-crack reinforcement mesh under the anchors with U-shaped reinforcement mesh to facilitate the installation of reinforcement in accordance with the design drawings. Ensure that the spacing of the reinforcement mesh is 10 centimeters and the distance from the anchorage devices is not more than 8 centimeters. After solving the reinforcement-related problems, let's turn to the concrete construction link, aiming at the cause of inadequate concrete vibration. The following preventive measures should be taken. Preventive measures for cracking in concrete vibration. Install external vibrators on the valves of the box girder to ensure the vibration of concrete at the beam ends. Resolve vibration position while installing pre-stressed ducts. During the pouring of the top slab of the box girder, assign special personnel to vibrate the reinforced concrete behind the anchor with a 30-tap vibrator. Strictly control the vibration time to avoid insufficient vibration, missing vibration or over vibration, so as to ensure this vibration and cement paste bleeding on the concrete surface. Subsequently, aiming at the third cause of inadequate concrete curing control, we have formulated corresponding preventive measures, which we will elaborate on next. Preventive measures for cracking in concrete curing. During winter construction, formwork can only be removed when three conditions are met. The surface temperature of concrete cools down to below 5 degrees Celsius. The temperature difference between the internal and external parts of concrete is below 20 degrees Celsius, and the concrete specimens cured under the same conditions with a corrosion strength against freezing. Affected by high temperature in summer, to avoid drying shrinkage cracks caused by water loss on the concrete surface due to perimeter formwork removal. Carry out curing by sprinkling water with the formwork installed for 1 day before removing the formwork. The sidewalk formwork of the box girder can only be removed when the concrete strength reaches not less than 2.5 MPa. Without it chipping and concrete corner damage, and the appearance quality of the concrete is guaranteed. After removing the said formwork, start the automatic sprinkler system in the girder yard in a timely manner of conduct sprinkling, curing on the girder body. The curing period shall not be less than 7 days to ensure curing effectiveness. Focus on sprinkling and curing and covering curing with or textiles and at the beam and to maximize the strength of the concrete at the tensioning ends. Preventive measures for cracking caused by tension-induced upward camber of box girders. When setting reverse camber of the girder fabrication bed refers to the reverse camber parameters in the drawings and make the longitudinal direction of the bed into smooth curved circular curve or quadratic parabolas. Strictly control the element of the bed through adjustable fastens or set cylinder. Finally, after the overall installation and forming of the bed, conduct fine adjustment with a precision level to ensure the accurate reservation of the reverse camber value of the bed, so as to reduce the upward camber of the box girder. Finally, aiming at the 6 causes of cracking due to exclusion from the wedge blocks at the bottom of the girder. Let's learn about the relevant preventive measures. Preventive measures for cracking caused by exclusion from wedge block at the bottom of the girder. The reserved grooves for the wedge blocks at the bottom of girder shall be made of stainless steel with a longitudinal slope of 175 along the bridge. Before blending the reinforcement of the box girder, apply silicone grease on the molds and then place rubber strips to reduce the transverse cross between the wedge blocks at the bottom of the girder and the box girder. Avoid strength concrete at the girder and caused by tensioning, thereby reducing the constraint of the wedge blocks on the upward camber deformation of the girder body and prevent tension-reduced crack at the beam end. Due to the varying lengths of box girder, the positions of the wedge blocks will change. When arranging the wedge blocks, adjust the size of the wedge blocks or increase the length of bed to ensure accurate and close contact between the wedge blocks and the bearing, so as to guarantee universality. The formation of tension-induced cracks in simply supported pre-stressed box girder is a complex process caused by multi-factors. Improper treatment of crack in box girder will not only increase the cost of defect treatment but also affect the progress of box girder prefabrication. In several cases, it will directly threaten people's lives and proper safety in view of the serious consequences caused by the quality hazard of box girder cracking. The construction shall focus on the method of prevention first, process control and comprehensive disposal. By adopting the preventive and control measures for tension-induced cracks in simply supported pre-stressed box girders, the quality problem of tension-induced cracks at the beam end of the box girder is effectively solved, achieving good application results. Over the years, with our high-quality products and professional services, we have won high recognition and praise from numerous customers, from the pre-project consultation and to the after-sales service. We have made our customers feel completely at ease. This is not only our honor but also the driving force for our continuous progress. Whether you are facing a bridge construction project in complex terrain or have special requirements for products, we help provide you with tailor-made solution to meet the needs of various bridge construction projects. If you have any relevant business needs, please feel free to contact us at any time. We look forward to working with you. Welcome to stay tuned to our live broadcast.